Alhamdulillahi Rabbil Alameen. Wassalatu wassalamu ala Sayyidina Muhammad. Amma ba'd. So, the other contention that some people or some atheists raise to the arguments that we proposed is this idea that we are assuming causal principles, and causality is not a necessary reality that exists on a quantum level. And therefore, if it doesn't exist on a quantum level, how can we be 100% sure it exists on a macro level, meaning on the big level, the level that we exist at and that we can see? So I remember one time, one person, he made the point that, it could be theoretically that as you go and reach out to grab a cup, that your hand could go straight through the cup. So I responded and I said, well, imagine if you were to walk in the middle of the road and you saw a truck coming towards you. Would you think at that moment in time, theoretically, the truck could go straight through you? Or are you going to try and get out of the way as fast as possible from that? But we want to dive into a little bit more detail regards to how we can understand and how we can approach this discussion. And really, the approach of this discussion shouldn't really be approached from, well, actually, quantum level does have, causal principles. I suppose that is one argument that you can use. I go into the science of it in order to refute the science that they provide or they counter with. But I think the problem with regards to quantum mechanics is that it's a complex issue. It's an issue which is counterintuitive. It's not what we expect to see. And because it's not what we expect to see in our general experiences, it can be quite confusing, quite difficult to understand what's actually occurring on a quantum level. What is quantum mechanics? All of these things. So rather, what we're going to do is approach this from a more of an epistemological point of view, meaning from the point of view of a rational thinking human being, and from how we understand ideas, and looking at where this then discussion about quantum mechanics fits in. So what do we mean by the quantum level or quantum mechanics? Quantum mechanics deals with the very, very small. So we're talking about the subatomic level type particles and the behaviors of things like electrons, photons, and the interactions even of atoms. But it's on the very, very small level. And on a quantum level, there are very weird, observations that are seen. For example, I'll just give you an example of this. So imagine, again, a pool table with all the balls racked up. And imagine you hit all these balls with your white cue ball. So if the pool table is a normal size, then theoretically you can work out what's going to happen to all of those pool balls, where they're going to be, what position they're going to land in, etc. So long as we've worked out all the variables, like for example, the variable of each weight of each ball, the size, the position, the friction of the table that exerts itself on each and every ball on the pool table. And if I knew the direction and speed of the white ball as I hit it. So if I knew the white ball, the speed, the direction, and if I knew everything else, all the other variables in regards to those pool balls, then I could possibly, or I can predict where each of those balls are going to land on that table. And that's obviously something we can predict. And yes, we know that causality is not something we can empirically prove, as we mentioned in a previous video. Meaning, using science, you have to assume causality. And if you have to assume causality using science, then you cannot refute the idea of science, or you can't prove it from a scientific basis. You have to assume it. And we also have to assume in science that there are fixed patterns of behavior. So when we're looking at this pool table, we understand that there's the effect, which is, the cause, which is the white ball traveling, is going to cause a various number of effects. And those effects are repeatable. They're going to be with a fixed pattern. So we can understand that. And we understand that because these things occur, and they are not things that occur because of the universe, they are the attributes which have been placed by Allah subhanahu wa ta'ala upon the universe itself. And therefore, we can, as a result, predict things because we assume that Allah subhanahu wa ta'ala, or Allah subhanahu wa ta'ala has told us that He has fixed laws within this universe. However, let's take a step back from the macro level, from the big level. And let's imagine this pool table and shrink it right down to the quantum level. So you've just got this really small quantum level size pool table. And suddenly now, if I try to hit the white ball, I have a few problems on this quantum level pool table, because I can't 100% predict exactly where that white ball is, and I cannot 100% predict at what speed or motion it will travel at. In fact, the problem exists on a quantum level is that with quantum level particles, you can only you have only a probabilistic assumption of both speed and position. Now, if on a macro level, because I knew speed and location of each ball, then I can work out what's going to happen. But if I don't know the speed and the location precisely of each ball, then I can't predict what's going to happen to that rack of balls on the pool table at a quantum level. I can't know all of the variables, so I can't predict and determine exactly what's going to happen. And this is this understanding that you can never predict both the position and the speed of a quantum level particle is what's termed as Heisenberg's uncertainty principle, i.e. the inability to determine precisely the position and speed of each particle. Rather, as it mentions this principle of Heisenberg's uncertainty principle, the more precise your measurements of the speed, the less precise your measurements will be of position, and vice versa. So some say, as a result, that theoretically, if quantum level interactions can't be predicted, so you can't say A is going to hit B, that's going to cause C to occur, because you don't know where A is at any given time, or you don't know its motion at any given time as well, both together. So as a result, if they say you can't predict quantum level interactions, then the macro level can't also be predicted or determined. So I want you to think about this. If a house is made up of bricks, then I know what the material of the house is. It's the bricks. So what they're saying here is that the big world, the world that we live in, is made up of quantum level interactions. If there are causal, means that don't follow causal patterns on a quantum level, and the macro world is built upon the quantum level interactions, then I can't predict, even on the macro level. Because if this is a causal and this is what makes up the rest of the universe, then the universe ultimately must be acausal or doesn't follow causal principles. And some scientists also give other examples or implications of this idea of acausal quantum level acausality. For example, the famous physicist known as Lawrence Krauss, and also self-declared anti-theist. He doesn't even consider himself an atheist. He actually calls himself an anti-theist. He states that the nothingness of space causes particles to pop in and out of existence. So when you have no space, you have a vacuum. In a vacuum, you find that there are, on a quantum level, there'll be particles that will pop in and out of existence, virtual particles. And again, what he's attempting to do is he's attempting to say, well, if that can occur on a quantum level, why couldn't this occur prior to the universe? That the universe didn't exist, it existed, there was some empty space, and the universe, or suddenly on a quantum level, a singularity appeared, and from the singularity there was a Big Bang. There's far more details in this that I haven't really gone through, huge amounts of details on quantum mechanics. But really, what we're really asking is a question about how do we approach this from a epistemological angle, from point of view of ideas. How do we the methodology of our thinking? So, however, when we talk about quantum level having no causality, as some claim, what they're actually saying is that quantum level interactions have no materialistic causation. You can't work out why, in a deterministic point of view, why this is occurring. Why one level interaction is taking place with another level interaction precisely in a deterministic fashion. So this is the first thing that they're really saying in regards to this. So the question then becomes, okay, how does claims that on a quantum level having no causality, as some claim, actually refute our argument for the existence of God? Does it? Does it refute our arguments for the existence of God? If there's no causality on a quantum level, there's no causality on the macro level, then does that mean that we cannot ask the question, what caused the Big Bang? That's effectively the argument. Well, firstly, no, we can't use that as an argument about acausality on a quantum level. Firstly, as we've mentioned in section 1 on science and scientism, we said that science is predicated on the belief in causality. You have to assume causality for you to engage in the scientific method. Even when we detect virtual particles popping in and out of existence, we are detecting them using machines also that rest on causal principles. So you're trying to detect, a particle that's come out of non-existence, or come out of, space, vacuum of space on a quantum level. You're using machinery that actually detects this. So you're not actually going outside of the causal principles. You're still using causality, even in the scientific method. The other thing is this: if some scientists or certain atheists try to use this argument to say, there is no causality because on a quantum level there is no causality, and that's what science has proven, then what they're doing is they're creating a circular or self-refuting argument. If science adopts the principle of causality and you conclude that there is no principle of causality, then you have actually refuted the scientific method itself, and if you refuted the scientific method, you've also refuted its conclusion. Secondly, causality is a necessary component to make rational thought. This means causality is an idea that we gain prior to experience. We use causality in order to interpret and explain experience, and we discussed this when we talked about the rational method. So we don't experience causality and then conclude causality exists, but rather we need causality to think. Because the fact that we think, that we have concepts, then we know reality exists. Because we know reality exists and that reality caused our thought, then as a result causality exists. It's a very basic argument. So even if we grant that quantum level interactions have no materialistic causation or no materialistic explanation, that's the key thing here, materialistic explanation, then that doesn't deny causality altogether. Rather, it only denies the explanation is materialistic or part of the universe. So if something's occurring and you can't explain what the cause of that thing that's occurring, that's caused its effect, then it doesn't mean that causality doesn't exist. It just means that the causality cannot be explained by the universe. And this is similar to how Imam Ghazali, he explained that there are no materialistic causation. So Imam Ghazali held a theological position called occasionalism, and this position basically said that there are no secondary causations. So I don't want to go into too much detail, but effectively what he was saying is that if you strike a match, it's not your striking that's causing the fire, but rather Allah subhanahu wa ta'ala has placed the attribute of the fire, and your striking in that situation is incidental. It just happens to occur side by side. And it also happens to be that Allah subhanahu wa ta'ala has made it that the universe operates according to this system, but it didn't have to operate according to that system. So the ultimate cause within the universe on every single event and every single effect that we see is Allah subhanahu wa ta'ala. He's the primary cause. This is what Imam Ghazali, when he said there is no secondary causation, he wasn't denying causality. They were in fact affirming that the only cause is Allah subhanahu wa ta'ala, and they said you have to still affirm causality. And this is similar to the point also we raised in section 2 about how attributes are not necessary for objects. Hence the attributes were also determined by Allah subhanahu wa ta'ala. So even if they say that on a quantum level there is no determinism or no materialistic explanation for the position and particle of the peculiar behavior of the quantum particles, or the particular behavior of the quantum particles, then that would reinforce our argument that the cause is not from the universe itself, but must be determined upon these particles. So if you can't explain the materialistic cause of why this quantum level particles popping in and out of existence on a quantum level space, in a vacuum of space, we can't explain why that occurs. It doesn't mean therefore causality doesn't occur. It rather means that the explanation and the cause is outside of the physical universe, i.e. Allah subhanahu wa ta'ala. So therefore the third point as well is this, is okay, let's say we grant and we accept that acausal quantum level interactions occur. But now we have to still explain why on the macro level we see causality. So why is it that each of the balls on a pool table and the pool table itself are made up of acausal interactions, but yet I can predict every single position of that ball? Even though when we start to reduce that pool table or shrink it down to the size of a quantum or quantum levels interactions, that we can no longer predict it. So we know that the big world follows causal principles. But if the big world are following causal principles and it's not because of the quantum level interactions, then as a result, the explanation of what's causing the universe to operate according to a system have certain fixed attributes that we sense, that we see, has fixed patterns that we sense and that we see, then that explanation again is not because of what it's made up of, but rather something that is determined by Allah subhanahu wa ta'ala. The final point that I want to mention in regards to this is that even when people turn around or scientists say that, oh, there's all these counterintuitive realities on the quantum level or in quantum mechanics, really, actually it's not, it may be counterintuitive, but they still follow patterns. They're probabilistic patterns, yeah, and therefore you can still predict in a probabilistic way where certain patterns or what certain particles will be, what will occur, etc. So for example, like the equation PQ approximates to Planck's constants over 4 pi, which is used in Heisenberg's uncertainty principle. So there is still equations that are used, and you don't see what we don't see on a quantum level interaction is we don't see complete acausality. So we don't see elephants being created on the quantum level. They're still following certain patterns in regards to that. The other point that I also want to mention is that Lawrence Krauss and what he said about the universe popping in and out of existence, or popping into existence from nothing, from a quantum, quantum singularity as being the start of the Big Bang, and the quantum singularity came from the vacuum of space. And he says that it is therefore valid to assume, and the science points to, the fact that something can come from nothing. This is what he's saying. Now, obviously, the first problem in regards to his question, this assumption that something can come from nothing, is that there's an effect, but there is no cause. That would deny the axiom of science, and therefore that would deny its own conclusion and its methodology. But really, we need to ask the question: what does he actually mean by this? When scientists, certain atheists, really push these ideas, what do they really mean by this? Professor Michio Kaku, who's professor of theoretical physics at City University in New York, he asks, how can it be that everything comes from nothing? Yeah, so how can it be that everything comes from nothing? And his solution, what he says, is that if you think about it for a while, you begin to realize it all depends on how you define nothing. Professor Kaku goes on to say, he goes, I think there are two kinds of nothing. First, there is something I call absolute nothing. No equations, no space, no time, no anything that the human mind can conceive of. Just nothing. Then there is a vacuum, which is nothing but an absence of matter. So he's saying there's two kinds of nothing. There is an absolute nothing, where there are no equations, and then there is an absence, a space which has absence of matter. Yeah, a vacuum that has absence of matter. And he goes, that's another kind of nothing. So Professor Kaku, he goes on to say, so for me the universe did not come out from absolute nothing. That is a state of no equations, no empty space, no time. It came from a pre-existing state, also what they call a state of nothing. Yeah, where quantum mechanics, the laws of the nature, laws of the universe, laws of quantum mechanics, the equations of quantum mechanics, they actually still operate. Our universe did in fact come from and he mentions an infinitesimally tiny little explosion that took place, giving us the Big Bang and giving us the galaxies and stars that we have today. Similarly, philosopher David Albert, he was a specialist in quantum theory, he offered a critique of Krauss's book in the New York Times Book Review. And he said, and this is his quote, "Where, for starters, are the laws of quantum mechanics themselves supposed to have come from? Modern quantum field theories," Albert points out, "have nothing whatsoever to say on the subject of where those fields came from, or of why the world should have consisted of a particular kind of fields it does, or why it should have consisted of fields at all, or of why there should have been a world in the first place. Period. Case closed. End of story." So when Lawrence Krauss and other prominent atheists attempt to argue that the universe came from nothing, they don't really mean nothing, but some kind of nothing, some kind of something. So even Professor Hawking, who claimed that the existence of quantum gravity would make the universe inevitable, again, he's assuming that there must be a quantum gravity to exist prior to the universe. So really, science does not point to absolute nothing producing something. Rather, it points that something is still dependent and contingent. And even if they were to claim that something is a causal, something did not came in from nothingness, what they are denying is materialistic causation, and will still be valid to say, not just valid, but it'd be necessary, logical and rational to say there must be an independent, unlimited creator to have determined its existence outside of the physical, natural causes of the universe.